Hey, today we're going to simplify the code for the ship, improve the portal system, and add the robots. Let's begin by simplifying the ship game mode. Alright, so we'll start off by removing everything except for the rotation. Now we're going to change the gravity scale, so we'll say rb.gravity scale is 2.93 times input.get mouse button, the primary mouse button, and like this. And this is already what we had previously as well. If the mouse is being held down, then gravity is flipped. And if the mouse isn't being held down, then gravity just stays the same. Now we're also going to limit the y velocity of our ship. So we'll say generic.limit y velocity. Our limit is going to be 9.95. And our rigid body is just going to be RB. And that's the entire new ship function. And as you can see, it still works perfectly fine. Now let's improve the portal system. You might be wondering, what's wrong with the current system? With the current system, we can't make our portal a trigger collider, causing messy and inaccurate collisions. Instead, we'll make a new system that allows our portal collision to have isTrigger on. So we'll copy this line of code here, and we'll remove the rest. Now we say public void initiate portal, and we'll also need the movement script for this. And now we'll just copy our line of code here. And then inside of our movement script, we'll add a new function, void on trigger enter 2D. And now we'll say portal script portal is collision.gameObject.getComponent. In here, we'll get the portal script like so. And now we'll check if that portal exists by just saying if portal. And now we'll say portal.initiate portal, and then in there we'll put in the movement script like so. So now we'll have to change the edge collider. We'll add a box collider instead and just make that isTrigger. And now as you can see, it will still work. So next up, we're going to implement the robot. Let's divide the jump into two sections, the first half and the second half. The first half is controlled by the player. The duration changes depending on how long the mouse is held down. The player has no control over the second half. The player falls down. What is convenient for us is the fact that the first half is a straight line. In other words, we get to avoid complicated physics calculations. However, the robot still has a few conditions. So let's go over those. We have to be on the ground. The mouse has to be held down throughout the first half. And lastly, we need to limit the length of the jump. Otherwise, the player can go up forever. Alright, now let's implement the robots game mode. So we'll start out by scrolling up to the game modes enum, and we'll add the robot over here, make it 5, and of course making sure that the spider is 6. And now we scroll all the way down, and here we add avoid robot. So we're going to start off by defining a few variables. We'll start with the start position of the robot. So we'll say robot x starts, and we'll just put this to like -100. Then we'll say bool on ground processed, and also bool gravity flipped. And that's everything we're gonna need. So we're going to start off by checking if the player is not holding down the mouse button. So we'll say if input.getMouseButton 0 like so, then click processed is going to be false, because there's simply no way our click can be processed if we're not actually holding down the mouse. Now we're going to say if on ground and not click processed and input.getMouseButton like so. And now we're going to change a few variables. We'll start off by saying gravity flipped is false. Next up, click processed is true. Then robot x starts is transform.position.x. Then we'll say on ground processed is true. And this essentially checks whether the user is on the ground for starters and if we're holding down the mouse. So this is the first frame of our jump. Alright, now let's add the rest of the robot. So we'll say if math.abs robot x starts minus transform.position.x. And now we'll check if this is below or equal to 3. So now we're essentially checking if the distance between our current x value and the x value of the first frame we clicked is below or equal to 3. Now we're going to do if inputs.getMouseButton and ground processed and gravity not flipped. Then what we'll do is we'll set the gravity scale to 0 because we're going to be making a straight line. Then we'll say rb.velocity is equal to vector2.up times 10.4 times gravity. Now we'll just return. Now we're going to say else if input.getMouseButton. Then we'll say ground processed is false. And now we'll say rb.gravity scale is 8.62 times gravity. And also generic.limit y velocity, and as our limit we'll say 23.66, and our rigid body is just going to be rb. And that's everything we're going to be needing. Alright, let's test it out. So we'll go to the player and we'll change the game mode to robot. And as you can see, we have a working robot. There is one little issue now. Let me move the portal down so I can show you what the issue is. So now what you see is we kind of bounce off of the portal. There's nothing wrong with the portal. It's just that we didn't yet check if we're going through a portal, which should just stop the robot, right? And there's one very simple solution to this. We'll just go to our change through portal, and at the gravity here, we'll set gravity flipped to true. Alright, now let's check it out. And now as you can see, it doesn't awkwardly bounce off of the portal. So that's everything for today actually. It was kind of a shorter episode. I just wanted to finish off all of the game modes, get a few things out of the way before you can add things like orbs or pads or whatever. Regardless, I hope you enjoyed and see you in the next one.